Hello, everyone, and welcome to our fourth edition of Encora Talks. Today, our topic is exploring .NET as a front-end developer. Our speaker is Angel Daniel Muñoz. Angel has specialized in web development for more than 8 years, paying special attention to developments in the front-end landscape. His interests include all-in frameworks such as Angular and platform alternatives like web components and progressive web applications, PWAs. He has experience in the development of education platforms, rewards portals, and fintech services. Angel is always searching for new ways to use the power of web to improve organizations' time to market. Please let us know your questions through the chat. We will be answering them in our Q&A section after the presentation. Hello, Angel, and thank you so much for being with us today.
Hello, Daniela. Thank you very much for presenting me. Let's get started with this, right? So today we will be talking about how is it .NET for the front end, for the average front end developer. So the agenda for today is what is WebAssembly? What is .NET? What is Blazor? Let's show some code samples and what does this mean for devs and CTOs? After all of that, we'll have some time for questions in case you have some, and let's dive in. So first of all, what is WebAssembly? Uh, if you are a desktop developer or an Android or iOS developer, you are used to what is called native applications, or you may refer to your applications as native because they get compiled down to machine code. That machine code runs directly on your operating system without anything in between, right? So in the web recently, we only had one way to run web applications, and that was just using JavaScript. So uh, this organization, the WebAssembly organization, set up to basically get a binary instruction format that could work for any kind of language that could compile into this instruction set. So this is how WebAssembly was born. And if you have heard, for example, Photoshop recently made a progressive web application that runs natively from the web, it's because of the power of WebAssembly. So what is .NET? Usually I would not include this part because, well, I would guess that .NET is pretty much known, but I have heard some myths that are still prevalent in some circles around the communities outside .NET. So part of those myths are that .NET is just for Windows, that it is very slow, that is very cumbersome, that it has a bunch of legacy code that is not really what you would call a hipster kind of language or platform to develop with. It's not JavaScript, it's not Rust. So I think these myths are really unfounded. .NET today is very capable of almost anything. It can run on phones via Xamarin. It can run on servers. It can run on websites, as we will see in a little bit. It can run on embedded applications, Internet of Things. It can run on Windows, on Linux, and Mac OS. And actually, the demos that we will see today are built and run on Mac OS. So if you have heard those things in the past, please let me tell you that those are myths. We have a different set of uh, opportunities with .NET today. So, wow, this all of this context, right? So we spoke about WebAssembly, and now we spoke about .NET. So, what is Blazor? How does it fit in all of this? Blazor is basically a web framework built on top of WebAssembly that in turn is built targeting .NET. So basically, you run .NET code, be it C# or F#, to run web applications, just like you use TypeScript, but rather than compiling to JavaScript, you compile to WebAssembly. Instead of running JavaScript on your browser, you mostly run WebAssembly. There is still a small portion of JavaScript that you must run, and that's mostly to set up the runtime that is going to run within. But all of your applications code, all of your logic, all of the shared information that you can have runs specifically on WebAssembly, right? So you can use F sharp, you can use C sharp, and even if you don't need JavaScript, you may still interoperate with third-party libraries via some interoperation mechanism that are part of Blazor. So, for example, what could be appealing? You may think, if I am already a React dev or Angular dev, what does it do with me, right? Blazor is basically just .NET. So if you're looking for something different, for something new, if you want to change your stack, if you want to start moving around without like really leaving behind all the knowledge that you have, like being front-end developer and building knowledge over the years is not an easy thing. It has its difficulties. So what can you take if you try a different thing, right? If you want to inject a breath of fresh air into your career. So if you're a React developer, you may be somewhat familiar with concepts like functional programming or functions as a view. So with F sharp, in this case, you can have first class function components. So you can still write functions and get your components that describe your UI. You still have a strongly typed DSL, just like GSX. In this case, F sharp has stronger type inference and stronger type correctness. So it can be an improvement depending on how you use it. There is also hook-like abstractions, unidirectional flow, some sort of immutability concepts that are slightly more prevalent on F sharp than in JavaScript or TypeScript. In the case for Angular devs, so you may already be comfortable doing services, dependency injection. You may already be pretty busy with concepts that you have like spent some time trying to learn with. Do these will serve for you for something? Well, yes, you can translate most of those concepts to Blazor with C sharp. So if you know what is dependency injection, you will feel at home here. If you like to segregate or separate information or have real interfaces, not mock interfaces like TypeScript has, that well, they're not really real interfaces, but if you want some sort of those object-oriented functionalities that languages have, C Sharp has better semantics for that. You have better class encapsulation, you have class components as well. You can also use your forms validation and other concepts that you may be already familiar within Angular, but in this case, they apply to C sharp as well. So even if you think that you may not take most of it, you are already there, almost there. So it won't feel really that different. So let's check two of the code samples. First of it, this is just a simple website. If this is the version of C sharp. So if we load right here this, we'll see that, yes, there's a couple of JavaScript calls, but these are just calls for Prism to do highlighting because we're rendering Markdown, you'll see in a little bit, and an icon library. But other than that, there's nothing here that says basically that you're like loading more JavaScript than that, right? If I try to search here something like dealing, it makes a call to our backend. gets a JSON response and does its thing, right? If we move it around, we do another call, and we have our JSON response. So this is your basic PWA that you may be familiar with if you have worked with this before. So it's nothing complicated. If you click on one of the blocks, it loads the block, it renders the markdown website and shows what could be a blog, right? This is not really a super complicated application. It's just showing some markdown file rendered on the client. If we go to the F# version, it's the same. Well, for some reason, it's not showing the tags, but if we do the search, it does the search as well. So these are two different applications. One is with C#, one is with F#. Let's check some of the code. In this case, our server is an ASP.NET application using what is called minimal APIs. So if you ever done something like Node.js Express or other similar frameworks, you might find this fairly familiar. There are some other concepts that apply only to ASP.NET, but most of it will feel fairly similar. For example, in this case, we're just registering some services, applying some middleware, and then we're making a call to a Mongo database. Then we have our endpoints. Our endpoints are just maps, gets, some posts, and a put, right? This is our server. This is the server that we are using for both applications. And also we have a shared library. So this application is called Marquee. Marquee core basically has our types that we're going to share between all of our applications. So core is shared between C# and F# as well as the server. So this is one of the parts that you can start thinking how you could improve and start moving also to the full stack role if you wanted, because you are using .NET code. In this case is F#, but it could be a C# library as well. You're not limited to the language. They all compile to the same binaries that can be used across C# and F#. So in this case, we have our core library that is going to be shared between these projects. So this can help us also to share common logic and other things like or models or types that can help us model the rest of our application. In the case of the F#, in the case we start with a variable that is called app, that is not really variable because it cannot change, but this is basically the DSL that we were looking at before. And this DSL is just the HTML tags, but they are also, this DSL is just one way to represent HTML for our application. In this case, we have tags like article, tags like main. We're also using class attributes, and we also have routing. In the case of F#, the routing, we do it directly in the code. So basically, this is just another component that, depending on the route, it takes a function that will render a component inside. So it will. We can also take parameters from the routes, and we can render our application depending where we're visiting. In the end, we just try to have a builder that is going to be useful to add services and also apply something like dependency injection in case that we have to do it. And lastly, we just start our application. Let's quickly see the FsBlock. So FsBlock is just a class that has some static members. In this case, these static members are returning what are our components. For example, we have the block list here. If you have ever used reactive extensions for JavaScript, you might feel like recognizing this kind of code. It's just basically uh, creating an observable from the uninitialized event, and from that observable, subscribing and fetching the blocks in the initial attempt. Once that we have initialized, we will have like the list of logs that we can see on there. We also have to fetch the tags. So what we do here is just fetch the tags, uh, map those values into a record that we can use later on to describe these. And then we have something that is called adaptive use. Adaptive use is just the way that we use to handle stateful components. So for example, if the article section header were outside adaptive view, they would be basically static content. They wouldn't change at all. But with adaptive use, we can use some stores and adaptive values to let the framework know, hey, this particular value has changed. Whatever you're using, this value should be re-rendered. Rather than re-rendering the whole tree, we're just rendering the portions that we need. So let's check one of the components. So we have two components here, blog post search and blog post list. So let's check the search component pretty quick. So it has private module that has inner components, in this case, a tag list item. We also have the blog post search. We have a text query, a tag query, because we're using stores here. We are also having a handler because when we change the tags that we're selecting, or if we are writing and changing values on the search box, we will need to handle those. So I can repeat that. If you have used reactive extensions before, you will see that we're basically just throttling the inputs on the text query so we don't hit our API like 100 times per per second or something like that when people is trying to write whatever they want to search for. And the same we applied for the tag query. So if someone is trying to change tags pretty often and also writing, because some people is really fast, we can throttle that information and we can hit our API just in one hit. So in this case, we also are taking our tags with our inside a store. We use adaptive view to pull that stateful data and let the framework know what they need to render. So there is not a lot much more here. It's just basically a component. We also are handling an input event. So whatever you usually do in JavaScript, that you can handle inputs, that you can place attributes, that you can have reference to elements and things like those, you can also do this as well here. In this case, it's not really necessary. We're just doing some really, really basic thing, like just showing blog posts. And also, for example, here, our blog list is a pretty simple order list that has a bunch of list items that has a link to the post and then just render part of the post. It's fairly simple, I think. So as I was saying, for the React lovers out there, this is basically what you would say it's a function component. So the function component takes some parameters, sometimes properties, sometimes stores, and then from that you just render a component. Depending of your necessities, if it's stateful or not, you may or may use stores or adaptive values or changeable values to achieve your goals. There's not a lot to do there. So let's check now the C# part. So in the C# part, if we go to the program.cs, we can see that things are fairly similar to what we were watching in the F# part. But in this case, F# code tends to be uh, F# DSLs are just F# code. They are not some sort of markup language or something like that. But in the case of C#, C# leans more on markup languages like CSHTML, or also called Razor. And it's easier for them to just work with Markdown. In the case of F#, we just try to handle things in code, and C# has different design block, design objectives. Let's check the index for us. So this is where Angular devs might feel more familiar. So you might done some components in Angular before. This is no different. If you define your component, you will define some properties. You will bind to those properties. You will have some events. You will bind an event to those, an event handler to those events. You also have your usual HTML class, your on order list. In this case, we made a block list item that we're printing a post, that we're passing also a parameter that is in an href. We're if you've done some nullable management in TypeScript, you might recognize these. So these are just ways to ensure that you're not dealing with potentially null values. So your code is slightly safer. And rather than defining some of these code in different files, the C# takes the approach that it should be able to define the code in the same place, just in a specific area for it. So also if you have done Vue, this is like the script part of your Vue templates. So it's fairly familiar. The case of initialize to sync, rather than subscribing as an observable like we did on the F# version, we are overriding the method here, and we're trying to do things right here. And in the case of the unblock search, so this handler already knows that we are going to have a paginated responsive blog post. So we're simply just let the framework know, hey, we are going to reassign this value and that state has changed. So it can render properly whenever these paginated content changes. And in the case of the blog, it's not much complicated than that. We also, something that I forgot to mention on the last one is that we have routing directly on the Razor files. So for example, we are just declaring here that we will have a post ID, and it will fall directly into this variable right here. Oh, sorry, into this one right here. So whenever our browser meets certain URL, like the one that we have defined at the top of the file, then it will assign that value into this parameter, and we will do the rest of whatever we need to do, right? In this case, we will also initialize this component by fetching the post that we are getting from the routing. And if the post is not null, we will just render the post, right? We will render from our core library, because if you remember correctly, this is from Marquee code. So we are sharing the same methods, or what we could say core methods, functions, and other functionality to both applications. So depending on how you structure your projects, you could even share core library to your core logic from your business to multiple applications that may have there. So it is a really powerful way to share code between even projects or even multiple teams, right? So let's check lastly the search component, because the search component might be slightly different. So as you can see, we're just Um, in TypeScript, we will usually use something like imports, like as module imports. In this case, we're using namespaces to make things available and also implement an interface that is called iDisposable. This is like this is a way that you can signal the framework that, hey, I am not using this instant of this class now. You can release all the resources that are available for this. So this can help you to save memory and as well to ensure that you're not keeping unneeded memory being used. So in the same way, we're just rendering the tags. We have also an input that we're uh, also attaching an onQuery handler. And we also have two parameters. One is the tags and the other is on blog post search. So the parameters are basically just the same. What we bind to them is a different thing. For example, one of the parameters we're binding an enumerable, and the other we're binding an action, so that you can pass the correct information and also have IDE support on those parameters. So on the uninitialize, we will also reuse their observables and also just handle our subjects we have here. Yeah. So again, reactive extensions, if you have used subjects, you know that these help you to emit values over time, and you can dispose them when they are not needed anymore, but they can be really powerful to describe flows and handle events in an asynchronous way. So basically just anytime someone is typing on the search box or changing the tags, what will happen here is that uh, we will do a different query, right? If the tags change, we will basically just check that we're searching something different than we did last time, and then just update. And in the case of the inputs, we're just going to update the whatever we try to find, whatever the API responds with. And once the API is done with it, we will just try to invoke in case that the user provided the handler for on-block search. And if it's there, we'll just invoke it and let the caller do whatever they want with it. But yeah, that's mostly it for this. So basically, we have different ways to do similar things, but none of these required extensive knowledge of JavaScript, or also didn't require something different that other than .NET itself. So this, if you are familiar with .NET, this concept might be already in your tool belt, so you can start looking at that. And if you are not in the .NET environment and you're looking for something new, this is really cool and fun to learn. Where is there it is. Okay, so that's it for the code samples. I didn't want to do something really complicated, but I'm just trying to show what is possible with it. So at least at some extent. So what does this mean for developers and CTOs? So if you're looking to switch stacks, this is a really great opportunity for you. If you are a front-end developer that is trying to look into something new, .NET, it's a really good option. You could also, rather than just completely switching to backend, you can start working your way through the full stack aspect, like trying to at first getting to handle some front-end development with .NET. Once you're comfortable with .NET, you can start transitioning to the backend, and the same way could be done for the backend developers. If you already know .NET and kind of looking for something new, you could start looking into the front end without leaving what is your if you're a backend developer, you can start working your way through the full stack aspect as well without leaving your comfort zone. Uh, you will face new challenges, but at the same time, you will have the tools that you know already there. In the case for CDOs, this could mean that you can leverage existing talent. So if you already have developers from the backend and you are looking to also let them have different challenges so they can fulfill part of their careers, you can start looking into Blazor so your developers can start learning new things so they don't get like stuck at only one aspect of the stack. For TypeScript developers, this could be fairly easy. TypeScript is more similar to C# than you might think. So I think you would feel at home with that. So here's the questions part.
Thank you so much, Angel, for all this valuable information. As you just said, now it's time to start with our Q&A. Our first question is, what will be a great place to learn more about .NET Core?
Sorry. Well, the best place to learn about .NET in general is just go to the .NET Microsoft website. There's a lot of free tutorials, courses, and all kind of information that you can use and, well, learn from there. So that would be the best place to go. Um, yeah.
Thank you. The second question we have is, how is this different from transpiling TypeScript or any other language to JavaScript?
Well, this is different in the sense that the code that you run on the browser is machine code. I mean, the code that gets compiled natively by your toolchain, in this case .NET, it gets compiled directly to code that is just machine code that can be interpreted by the browser and is not JavaScript. There's your application code is never really using JavaScript unless you call into JavaScript, but that's a different thing.
Okay. Can I interoperate with a third-party JavaScript libraries?
Yes, Blazor offers a set of interfaces and helpers that can be used to call existing JavaScript. So it is not like you're totally isolated from the JavaScript world. If you need, for example, if you want to call uh, a library that is dedicated for mathematics or a library that is dedicated to render graphics on screen that is not available on .NET yet, you can do it. It's not impossible.
Thank you, Angel. And our last question is it possible to transition to a full stack position with these technologies?
Yes, this is just like people that have learned JavaScript, Node, and frontend. They can like claim that title of full stack developers. This is the same case for .NET developers because your front end code is just .NET, your backend code is .NET, so you are completely there in the full stack aspect. It's completely possible.
Okay, Angel, thank you again so much. And thank you everyone for joining us. Please keep an eye out for more webinars that we'll be hosting soon. We also invite you to watch the recorded webinars we have posted on Encora.com. Thank you again.